Welcome to another podcast. This episode we're going to be taking a look at a corollary of the ratio test known as the root test. Basically, the idea behind the root test is if you're asked to evaluate an infinite series where the terms of the series are multiplied by the index, in this case being n, then what we'd like to be able to do is take the nth root of the terms and apply the ratio test at that point. And so the basic idea here is that if we can take the nth root of the terms, you can see here that we have the absolute values of the terms. If we can take the nth root of those terms and then the limit of those terms converges to a value L and that value is less than 1, then we have everything we need in order to conclude convergence or divergence based off of the same L values as the ratio test. So this is the L being less than 1, it converges absolutely. L being greater than 1, it diverges. And L being equal to 1, it's inconclusive. And so for this problem, we look at the absolute value of the AN and then take the nth root. So if I take the nth root of the general term of this sequence, so the nth root of this would be that, then that's just 1 minus 1 over n to the n squared times 1 over n is just the nth power. And so if I now look at the limit as n goes to infinity of the absolute value of that, then this limit is the same as, I can drop the absolute values now. I know all the terms in here are positive. This is for values of n going from 1 to infinity, so I'm okay here. And this limit is related to the exponential limit that we looked at previously. This limit turns out to be e to the negative 1. Remember, whatever this value is right here is the r value, and you get e raised to the r. So this is e to the negative 1, or 1 over e. And it turns out that this is, about 1/3. It's close to 1/3, but the point is it is less than 1. And so because of this, I know that the original series must converge by the root test with a limit value of 1 over e, which is less than 1. So this is very similar to the ratio test, at least the conclusion of the test, but all you have to do is take the nth root of what you're looking at, and if you happen to know the limit of the thing that comes out of that, and that limit is less than 1, then it's going to converge. So the same basic idea as the ratio test, just you're not looking at a ratio anymore, you're looking at the root, hence it's called the root test. So all totaled, we have several different convergence tests at our fingertips now. We've got integral test, ratio test, root test, comparison test. All of these are going to give us a picture or a window into whether a given series converges or diverges. And it's your job to figure out when I need to apply which rule and what each rule tells me about the resulting series. And that's going to be the difficult part, but it just takes a little bit of practice. All right, thank you for watching.